Hello guys, how are you doing? It's Monday morning and we have laptop to fix. Let's see whether we can help this customer to salvage this laptop. This is a 20 G3 or G4, I believe it is one of them. This laptop, the customer said it's not powering on, and the customer have no idea what happened. He said that the laptop just died. This laptop is coming from the computer shop. That's why you can see it has already been opened. Yes, that's been opened. I don't have the RAM, no SSD, no battery, no backlead. Yes, some parts are not in with, they're not, it was not brought in with those parts. As always, we plug in the laptop to the power supply and see what is happening. The good thing about using the power supply is that we are able to see how much voltage is being injected by the motherboard. Again, we are able to study and interpret the behavior of the motherboard. How much current is intaking, whether it is normal, whether it is abnormal, whether it is a short, whether there is no power at all. We are able to see them through the power supply. That's why it's good to have the power supply. In laptop repair or in any electronic repair, you must invest on the tools. Yes, we have tools which are compulsory. We say we have compulsory tools. We have tools which are recommended. And then we have special tools like infrared camera and those other tools which are very special. Power supply fall under recommended tools because it is recommended because it will make our work easier, and again it enables us to study the behavior of the motherboard. As always, we plug in the blue pin. This laptop uses the blue pin. Plug in the blue pin jack for the power supply and see what is happening. When I plug in, the laptop is taking 57 milliamps, 90 milliamps, and then back to 48, then 50. Yes, and there's a certain LED blinking here. Can you see? I don't know whether you can see it. Can you see the switch? Yes, there's a certain light here. There's a light here blinking. Yes, that tells me there's a short. It's either the shorted component within the motherboard, or there's a certain component which is disturbing the power supply. Sorry for that. Yes, there's certain component which is either disturbing the power within the circuit, or it is a shorted component. Again, I cannot rule out the issue of spillage because in case I have a spillage, maybe a power supply component is corroded. Again, I can experience that issue because I can see the power supply supplying, like the motherboard is taking 40 something, 42, 43 milliamps, 50. Yes, it is just fluctuating there. So as always, I believe even if I try to switch it on, there is nothing happens. Yes, when I switch, nothing happens. Why? Because already I have that power disturbance within the motherboard. So what I'm going to do, I'm going to remove this motherboard from the casing. Then I work with the motherboard from the bench. That is when I will be able to study or to trace wherever there is a fault. Wherever there is a fault in this motherboard, I'll be able to locate that problem when I have the motherboard on the bench. Yes. And then so you can see somebody tries to program the BIOS because there's a sign of heat here. So someone tried to repair this. Which makes my work more trickier because working on the laptop with someone else tried to repair, it is very tiresome. I know you are my witness. If you haven't worked on the laptop with someone else tried to work on, I think you should. You should try. You should try one fine day. But those people who have experienced what I am experiencing or what I have experienced working on the laptop where someone else worked on, it's not the walk in the park because most of the time you're trying to rectify or you're trying to correct wherever there is a mistake. But sometimes again it is good because someone if especially when you're working on the laptop with someone who is very professional, someone who knows what he's doing, it's also make it easier for you because you will not experience hard time trying to fix that. You will be working on looking on whatever that other person failed to see. So I have the motherboard. Here is the motherboard. I am going to try and see what is wrong with it. As always, the first step to do when you have the motherboard on the bench, I'll plug in the power again and see whether I will have the same power intake or there will be something changed. Because sometimes you find that maybe the keyboard was the problem or the screen was the problem. Then when you remove your motherboard on the bench and plug in the power, you find that the laptop power is on without any issue. So as always, we plug in again 37, 47, 50. Still, it is taking the same milliamps, and I have the same LED blinking. Can you see that white blink? Yes. So it means the problem is not about the screen or the keyboard or anything else. It is the issue with the motherboard. I can see this person has tried to replace the power ports. I can see MOSFET 1 has been tampered with, MOSFET 2, the charging MOSFET. What else these guys have done? By the way, this one gives me where to focus on. Yes, because I can see it tried to replace the port. Probably never managed. He went to the MOSFET 1, MOSFET 2, and again it never managed. That's what it means. Whatever that guys were looking, there's something wrong with this particular area. However, I will not rule out uh, the main board. Yes, there's something here. Can you see this particular area? There's some soldering paste there. So I don't know whether there was a problem with this power supply PD controller or what. And in case if there is an issue there, this will be a very dangerous because these two power supplies there. As you can see, the inductors are coded 1R5, and then it is also 1R5 QA3 QA3. So meaning this is the family group. So probably this is the line for the 5.0 always and 3.3 always. We shall test the voltages there whether we have the 3.3 at this location. Here I should have the 5.0 and here I should have the 1.8. Yes, these are very important voltages. Without them, did you yes, yeah. I said this one I should have the 5.0 voltage always on voltage. Here I should have 3.3 always on voltage, and here I should have 1.8 voltage. So we are going to test whether we have those voltages. Then again, so before even we proceed, let's try and see whether we have the short in the main power line. Testing for the short in the main power line, you just have to have your meter. You need to have your meter. Your meter should be in continuity mode to be specific, beeping mode. Yes, my digital multimeter in the beeping mode. Then from there, I am going to put my black probe on the ground, and we say the grounds are these screw holes. The screw holes are the ground. Yes, my black probe on the ground. Then I need to confirm the baseline for my meter. I put my red probe to the same to another ground. Then I can see my meter is reading like 1.0, not 38, 1.1 there. So my meter is having like 1.1 ohms. So it means whatever I'll measure, then it will give me those readings, which is almost to 1.1 or 1.1 or even 0. It will mean that those things are connected. So the reason why we are doing this, because I want to check whether the main power line is connected to the ground. So you need to put your black probe to the ground. And we say the grounds are these screw holes. Then my red probe to the main power lines. And the main power lines, you can use this resistor, PR resistor 1. As you can see, this one shows no connection to the ground. So it means I don't have the short in the main power line. If you can see this at a particular area, I believe you can see this place. Let me bring it closer so that you can see it clearly. So, as I was talking about this power supply, this one, you see we have the inductor. We have some capacitors there, ceramic MLCC capacitors. These are ceramic capacitors or MLCC capacitors. We have this IC. This is called the BD controller for 5.0 always. Then you have other capacitors there. So this IC is the input power. So this one is the one which step down to the 19 to 5.0. Same case here. I have this IC which step down to 19 voltage coming from the main power line, step it down to 3.3, then pass it through this inductor to be regulated, then it is forwarded to wherever it is going. Same case applies here. I have 19 coming in into this IC, then this IC step down to that 19 to 1.8, then it is passed on to through this inductor, regulated here, then released to destination for that. Sorry for my heavy tongue. So I have 19 coming towards this IC. This IC step down that 19, then it releases 1.8. This one is regulated. This inductor regulates that 1.8. Then it is sent to its destination. So before any input of these power supplies, before any input, that is the input, that is the main power. So here I have the main power that, so here I should have 19. So this these are the testing points. These parts, these are the testing points. So we are going to test whether those testing points are connected to the ground. It should not connect to the ground. In case you put your digital multimeter one probe to the ground, then you test those testing points. Can you see? I don't hear any peeping. I don't see any low resistance. So it means there is no short in the main power line, right? Yes. If I don't have the short in the main power line, my next focus is to check whether I have the short in those power supplies inductors. Uh, so I start with this one for the 5.0 always. Here, no short. This one, no short. This one, no short. This one, no short. I don't have the short with those inductors. Then here, no short. What about here? Can you hear that? Yes, I can hear some peeping. I know some of you might think that we have a short there. No, we don't have the short. Why? Because these inductors, as you can see, these are the inductors which are supplying the CPU and the PCH. These inductors, they pip because we have a resistance from the CPU. It pips, but you see, it has some resistance. That is 10 ohms resistance. Do you remember the resistance from the ground to ground? That is 1 ohms, or even less than that is 0.9. What about this one? That is 10. So it means this one I have 10 ohms resistance. So that tells you the power supplied within the around the CPU. It will pip, but it has some resistance. Can you see? 10 ohms, that is good. Almost 10 ohms again, that is good. And again, there's something I want to tell you. This resistance from the CPU, they have to be similar, almost the same. You can see this one is 11, this one is 10, this one is 10, and it is 10.9, 10.9, 11.5. So they have the same resistance. What about here? This one I believe it is for the PCH, 23 ohms. And what about this? This one, no, it's not connecting to the. So this one and this one are the same. As you can see, the inductor, it is labeled R68. So meaning R68 820ZIX, R68 820ZIX, C1X. These are the same. R47, I don't see any other R47. Then this one I have R15A, R15A, R15A. So it means they are the same. So these inductors are the same. They are supplying power to the same location. So I believe you've understood something there. Yes. So have in mind, whenever you are measuring the inductors which are around the CPU, they must have some resistance. In case you find that it has less resistance, that is zero resistance or one ohm resistance, it means there's a problem. Yes, it means there's a problem. That inductor is basically shorted. Then I believe we found out that we don't have any short in the power lines, both the main power lines and the auxiliary power line. Then my next focus is to test whether I have the shorted component. And these components which normally short are the what? Are the MOSFET, the switches, power switches. These are the components which switch power from one particular point to the other point. Right? Yes. I think I am done with testing capacitor. Yes. Me testing the main power line to the ground. That's one way of checking whether there is any connection between the power line to the ground. And most of the time, what's short the main power line to the ground are the capacitors. So once I have tested and I found out that I don't have the main power line shorting to the ground, that means I don't have any capacitor which is shorting the power to the ground. That's why I said I am done with the capacitors. So my next focus is to test whether I have the shorted switches. That is the shorted what? The shorted MOSFETs. Then I can also test whether I have the shorted what? The shorted ICs. The shorted MOSFETs, we have MOSFET, this one. MOSFET, I have to test drain to source. That is this particular 4 points here. These are the drain. Then the 3 here are the source. Yes. Can you hear that? That's for sure. As can you see, it means the drain is connected to the ground and not to the ground, to the source. And you can see the resistance. It is 0.7. So it means this MOSFET is shorted. What about this? This one source to drain, not shorted. What about this first MOSFET? It hit the drain. Still, it shows that it is shorted. Okay. So far, I found out I have an issue with this first MOSFET. Then, even before we continue, can we rectify that? Can we ensure that we don't have any problem with that MOSFET? Yes, we're going to do that. To do that, I'm going to dissolve that MOSFET. Then, even means me replacing that MOSFET with another one, it is better. So I need to be sure that MOSFET is no longer having any issue before before we proceed from there. You know, whenever you found an issue, you just rectify that issue, then go to next. So this MOSFET is out. This MOSFET is out. Can you try and test it from the bench without being the motherboard? Or can you start the motherboard? The motherboard source to drain, no issue. So it means this MOSFET was the one shorting. Yes, this MOSFET is damaged. Can you see? Can you hear? It is beeping and it is reading one ohm 0.009 So this one it will go into nine dimension. Yes, that's what's normally not French said. But anyway, let's focus. I have the donor board here. Let me believe this donor board is good. Let me believe the MOSFET from this other motherboard is good. Yes, I am going to remove these MOSFETs here. Then before soldering it to the other side, I have to test it first. I have to test it first. Nice. So the MOSFET is out. Now, before I solder it into the other motherboard, because this is the MOSFET which I trust and I believe it will work. I believe it will work. Source. No, my man. No. Can you hear? It's also shorted. They decided to give me with the shorted MOSFETs. That one is also faulty. So I am not going to use that. I'm not going to use that because it is also faulty. I don't know whether I'll get another MOSFET. Huh? I don't know whether I'll get another MOSFET because I need to replace a MOSFET there. Just give me 1 minute to get another MOSFET there. Yes, I got another MOSFET. I don't know whether it's good or not. So let's test it and see whether it is good. Oh my gosh. What is not happening? Even this one is bad. Now this one seems to be good. Then why this one is, or this is the other one which I removed from the other motherboard. Let me just put it away so that it cannot confuse me there. What about this one? Yes, this one seems to be good. This one seems to be good. I'm going to use this one. I'm going to solder in this here. Then from there, is it the same MOSFETs? Let me believe these are the N channel MOSFETs. Yes, still the same. You know, we have two types of MOSFETs, N channel and P channel MOSFET. So you should know which one is which one. If you don't know, go and watch my videos. That's why I'm encouraging you to subscribe to my channel so that you cannot miss things like that. Yes, please guys, subscribe if you haven't, please. I'm still begging you, if you haven't subscribed to my channel, please do so. Now, the MOSFET is soldered. The MOSFET is soldered. We are going to, let me cool it down a little bit. Let me cool it down a little bit. Then we are going to test again whether it is shutting. I believe they're no longer shuttered. Yes, it's about the smaller one. No issue. Then, since I've removed the shuttered MOSFET, let's plug in and see what's happening. Plugged in, it's taking what? 16. It is taking 11 milliamps, but I don't see any LED here blinking. No any LED, and the laptop is taking 11 milliamps. So what is wrong? That's MOSFET faulty? Huh? Why is it not? Why is it not switching? And the laptop I can see is taking 10 milliamps. So it means the power is not going beyond MOSFET 1. Let's see the input for the MOSFET plug probe to the ground. Plugged in. Now it's taking 0.006 milliamps. The input 19.6. The output nothing. So I don't have any output. So what is wrong? Mm? You know, when when the laptop is not switching power from MOSFET 1, there are several things which come in play. Number one, that MOSFET itself could be the problem, of which I don't think that MOSFET is the problem because I just replaced it. Number two, MOSFET 2 could be the problem. It could be the problem because the system or the laptop, if it is having the short, the laptop will cut off power from MOSFET 1. That's why this MOSFET 1 is called block MOSFET. So I want you to get that MOSFET 1 is called block MOSFET because it blocks any reverse voltage, any power coming back. Again, another problem is the charging IC. The charging IC, let me just bring it closer to you so that you can see. Let me use that tweezer. This IC, this is the BQ24780S. So this is the charging IC for this motherboard. The charging IC is the one responsible for switching power from one particular point of the MOSFET to the other, from one particular point to the other. So in this case, this charging IC is responsible for switching power in MOSFET 1 and MOSFET 2. So when you have an issue with this MOSFET, if they are not able to switch any power, this could be also the suspect. And when I say the charging IC itself could be an issue, or the components surrounding that or supplying power or signals to that IC, they also could be the problem. So when I say charging IC, it could be the charging IC itself or the components which are around that charging IC. Again, another problem which could make this switch not to switch power is the short within the laptop motherboard. Yes. When the system detects the short within the laptop, that is, maybe you have a shorted capacitor somewhere, a shorted BD controller somewhere. So the system again will block power from MOSFET 1. The system tries to protect itself from any damage from the short. That's why it cuts power from MOSFET 1. That one you can rule out in this case because we just measured we don't have any shorted component, any short in the main power lane with this motherboard. So we rule out that. Then my next issue could be okay. So by now we rule out this because we just replaced the charging the MOSFET itself. Now we are only and then we have ruled out the short in the motherboard. We have ruled out the short in this MOSFET. Now we are working on this charging IC itself, and we also have this. This is what's called the SIO or EC chip. This EC is the one responsible for managing power within the system, within the laptop motherboard. Yes, that's why this IC, sometimes we call it mini computer. It's mini computer because it controls the power. It doesn't control power directly, but it controls power by controlling the PMICs or the power management ICs. Which controls power themselves. So in this case, this IC also is responsible for controlling this charging IC. How does it control the PMICs? They send out the enabling signals. They send out enabling signals to those PMICs. So now I'm working with, could be this one is the issue. It could be this one is the issue. That the surrounding components or even the surrounding components here could be the issues. So now I'm working on the two ICs. Good. Since I'm working on the two, I'll start from the simpler one. Because if I decide to focus on this big one, I might end up causing more damages because this one is more complicated to fix than this smaller one. As you can see, in fact, this one, even if I decide to replace this IC, can you see? If I may ask, which IC between this and this, which one is easy to replace? Of course, it is this one, because as you can see, this one has so many pins, so many. But this one, just a tiny one, and of course, then I have the replacement IC. So I can decide to replace this smaller one before this one. But again, as you can see, this one seems to be clean. I don't see any sign of corrosion. I don't see any sign of blown up there. So what does that tell me? this IC itself could be uh, could not be the issue, because if I had some corrosion here, that one automatically will have qualified this IC to be defective, to be that to be an issue. Since I don't see any sign of corrosion, there is none. There is no any corrosion there. But now my focus it will be on these components around them. Am I seeing anything wrong? And I think so. I think I am seeing a problem. I don't know. Let me just bring it closer to you. I don't know whether uh, yes. Let me hope my camera will focus. I have a resistor here, which normally written 100. So 100, that is the 3-digit rule. It means that is 10 times 10 raised to 0. So this one should have 10 ohm resistance if it is good, because it is written 100 on top. But I can see there's something like a dot. So I believe that resistor is blown up. I don't know. Let's measure and see. So we are going to use the resistance mode. The resistance mode. Let's measure that resistor and see how much is it having. So the resistor itself, in fact, it should have pipped. See, my guys, can you see? It is reading 1.0 kilo ohms. What does that tells you? It means that the resistor is blown up. Let me just bring it closer again for the second time. Here. How can I place it so that you can see? Okay, I'm so sorry. My camera is not focusing enough. There's a resistor here, which is written 100 on top of it. When you see a resistor written 100, that means that is 10 times 10. That is 10 times 10 raised to 0, which means what? That resistor should have what? 10 ohms, not 1 kilo ohms. You know, 1 kilo ohms is how much? Hmm? Yes, so it means I have an issue with that resistor. We can use our donor. We can use our donor. Yes, this is our donor. We can use this one to verify or to confirm our theory. This one, it is still within 100 ohms, but can you see 10.9? This is perfectly good, perfectly good. So what I'm going to do, I'm going to replace that resistor. I cannot go. I said, remember what we said. We are going to fix the problems one by one. Once we find a problem, we fix that problem before we go to next issue. So here we are going to fix this resistor first before we proceed until this laptop is fixed. We are going to help this customer by fire by force. We do not wish the customer to come back to buy another laptop. Yes, that's what we do. We do help customers not to go back to the market to buy a new laptop. Then I have that resistor out and then this one in. Nice, 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 nice. So the resistor is replaced. The resistor is replaced. Now we are going to plug in and see. You know that resistor, that I just replaced the resistor. I don't know whether you can see it, but I'm just trying to show you anyway. Let me take it a little bit away so that my camera can focus here. This resistor is written 100 on top. The other one, it was written 100 on top, but it was having what? Something else. It was having something else. Let me just solder it back correctly or properly. Let me solder it properly. That resistor is responsible for supplying power to the BQ. Yes. Since it was blown up, it means the BQ or the charging IC was not receiving any power. So it means it was not operational. Why? Because there was no power going into that IC. So we've replaced the resistor. Let's pray. The AC switch 20 milliamps, 19 milliamps, and it is not switching. But at least you are having a normal intake. 20 milliamps is good. When I try to switch, still nothing. Could it mean that IC before the resistor got blown up, the charging IC also went off? Remember, we say you're going to help this customer by fire by force. So let's also replace that charging IC. It's good. I have the replacement IC. Let's replace that IC too with this one. That one is out. This one in. Let me just put back this so that I don't lose this, because we are not sure whether the issue is this or we still have some other problems. Now, this one. So we've replaced the charging IC. So let's let me pull it back a little bit. Then plug in and see what is it doing. 60 milliamps. We are back to where we were. It's just blinking again. What the hell is wrong? Voltage mode. Let's check the power, whether it is flowing. Input 19.6. The output 19.68. So it means the power is going through 19. What about the always on voltages? I believe those ones should be there because already they were always on voltages. Let's check. 5, 3. Here I should have 1.8. Can you see those are the, remember where I was telling you, we have 5.32, 3.3, and then 1.8. I have the main power. What about this BIOS? I think my problem should be here, because these guys have tried to program the BIOS. It is not very good. This one is seems to be good. However, I'm not sure whether the firmware which was programmed here was a good file or not. Even this one, they programmed even this smaller one, and this one. When you're programming the BIOS, make sure don't always program the little guy. Yeah, the little guy is always someone might you might mistake it. When you program this, but you normally program the main BIOS, then it overrides the smaller one. It's good with me because I have the donor board. I'm going to use this one. I'm going to swap almost everything. So today it's about donation. Still, I'm going to donate the BIOS. I have donated the power I see. I believe so far now the power is stable, but my problem now it seems to be the BIOS issue. That one out. This chip is normally for enabling the power. Yes. When you are discussing about the power supply within the laptop, then we discuss about the factors which affects the power supply. BIOS was one of them. BIOS was one of them. Because this BIOS sends the enabling signal to the power IC. I mean, put this one back. I don't want to misplace these chips. It might help me tomorrow. Now, in case I suspect I still have an issue, I'll replace the other one, the main one. Sorry for that. Yes, my camera decides to dance. Yes, again, 20 million. Still blinking. Huh. Does this mean I'm still having sudden shot somewhere? Let's swap the main BIOS for the last. Let's swap the main BIOS again. Now the main BIOS. Once I swap and still I'll have the same issue, and that will be a dangerous. Let's swap this smaller one, which is coming in. That one is soldered. Now, what if I haven't fixed? What is next? What will be the fate for this motherboard? Because I think I have fixed almost everything. Everything which I was suspecting it was the problem, I think I have fixed it. So if it is still not powering on, what can we say? 20 milliamps. Oh, Can you see the LED is on? So the problem was the BIOS. It's now on. Eh? Yes, the laptop is now on. I don't know whether it is having any display. So what I'm going to do, I think the laptop is fixed. So let me plug in the RAM. Plug in the RAM. Then I need the screen. I need the screen. Let's see whether the issue is fixed. The screen. Uh-huh. The screen connected. The speaker just needs the speaker again. Speaker connected. Let me put some few screws so that it can help me to hold the motherboard in position. That one is screwed there. This one screwed. This one screwed. Next, let me connect these LED lights here. Connected. Let me have the keyboard again because I'll have to enter. I'm very optimistic the issue is fixed because the motherboard is powered on. Did you see now the kind of hardship I went through to fix this? Even after I fixed the power, the problem with this motherboard was the power problem. It was the power issue. So even after I fixed the power problem, I had to went back again to program the BIOS because the guy who was working on it before me decides to program the BIOS, and yet the problem wasn't even the BIOS. There's some people out there. The only thing they know is the program BIOS. So when they receive a laptop not powering on, BIOS, not charging, BIOS, no sound, BIOS, no power, BIOS. Tell me, those people. How can those people can be helped? How can we help people like that? You can see now the light is steady. Can you see? Yes, the light is steady. 400 milliamps. It started normally, started at 19, then it rises to 200, 380, 400. Now it's at 470, 500, 570. It should display. The fan is spinning and it is reading about 500 milliamps. 480, and it is restarting. That's a good sign. When you see a laptop restarting, it's back to that heat, then up. When you see a laptop restarting, the power supply coming down, then rising up again, that's a good sign that the system is rebooting. And that's good. That's a good sign that the laptop is fixed. Let's just wait a little bit and see whether we have the display. It might take some minutes because the system must reset since we programmed a new BIOS. Yes, the fan is spinning. It might restart 3 times. Sometimes the bell can restart even like 5 times. So you need to be patient a little bit. If this was the bell, I will have waited to restart like several times. Starting for the second time now, and it should be the final restart. Yes. If I will not have the display, it means we still have some problem. 600 milliamps, 470. No, restarting again. That's not good. That's not good. Yes, that is now 3 times. For HP, I don't think HP should restart that way. It should just restart first time, second time, then we should have to display. But this one, it seems like we still have some problem. The fan is spinning, but at least we have power. Yeah, but at least we have the laptop powering on. No, I don't think it will display. I do not think it will display. However, what I can do, you can try to boot back this BIOS for this, guys, or I can program mine. Yeah? Give me a minute. As we are waiting for the miracle. As we are waiting for the miracle. Let me do some programming here. Sorry. Let me do some programming. There is nothing here. It will not display. Yeah? It will not display. Just as you're waiting for the miracles, allow me to share my screen. Allow me to share my screen. Just give me a minute. I'm working on something here. Just give me a minute. Still nothing. This doing nothing. So let me share my screen and show how to program, how we are programming this BIOS. That is RT809F. That is the program I'm using to program the chip. Let me just put it this way. So I am going to place the chip into the programmer. I'm going to place the chip into the programmer. Then once I have the chip installed, I'm going to identify the chip. I'm not going to read it because it wasn't even powering on. And I trust the chip I am having, the file I am having here. Trust the file I'm having is a good file. So I'll skip reading. I'll skip there. So I'm going to open. Once I open, it will take me to where the BIOS files, BIOS bins. Then this motherboard is the 301, it's 2301. Just type 301, then whichever the file it will pop up. I'm going to take the 8, so I have 840, G4, 650, 840, 840. I'm looking for 820. Yeah? Then here I have the 820s. I have the 820. Let me take this one. I trust this one is good. Yes. Then we program the chip. Yes. Writing the BIOS, you can see you must identify. Once the chip has been selected, you can see currently selected this chip. Then the software confirm that. Then you load the file. You come here, you open, then you load the file which matches the motherboard you're working on. Then from there, once you load, you will just click right. Once you click right, you can see after you load the file, it says the file has been loaded. Then it's identified the capacity of that file you loaded. Then it will start erasing. You start writing, that is, you click right. Once you click right, the system itself start erasing the content inside that chip. Once the content inside the chip has been erased, then it will tell you it is erased successfully. Once it has been erased successfully, then it will start writing. These are the things the software and the hardware does themselves. Yes, here you are not praying any role, you just wait for it to complete the writing. Then so once the writing is complete, it will auto-verify. Yeah? It will auto-verify. Then after auto-verifying it, then finally you will have your new file. Yes, finally you will have your new file. And the problem will be fixed. So I'll have a new file for this. Then okay. So the chip has been programmed. So now I have a new BIOS. So I have programmed the new BIOS. So I am going to solder it into the. Let me go back. Nice. So I am going to solder it back. I am going to solder it here. And then again we are going to test. I'm going to solder it. Then we are going to test whether it is displaying or not. There's something I am seeing there. Oh, it should be that way. I see a particular place here which seems like there was a component there, a resistor. But from the other donor, I can see it is normal. Mm-hmm. Mm-hmm. So the new file has been programmed. Now, if I am not getting any results, what should I say? What should be the fate for this laptop? And I told you I wanted us to fix this laptop by fire by force. Then again plug in the power, taking 21 milliamps, and see the LED there blinking. As we wait for it to complete the cycle, I shall went off and then it will come back. Then now it should power on, and it is powered on. It is reading 500 milliamps, 450 milliamps. I told you it should not restart more than 5 times. Restarting for the first time, then coming back again. It should not go beyond 3 restarts. Once I have more than the restart, whoa, can you see 700 milliamps? Do not disturb. Do not disturb. Uh, System update. That's final system update. Do not reset or turn off or remove the power from the system during the update. Any interruption of the BIOS update process may result in corruption of the BIOS, making the system non-functional. If you disturb it, maybe you plug it out or you disconnect the power, you will start process again from the first stage. BIOS identify recovered data. Yeah, you just enter, and I believe we fix the problem. The customer should be happy wherever he is. Yes, because we fixed the issue. You see, it was we took more than 1 hour fixing this. It was very tough, right? Yes, it was very tough. This one I'll have to judge the customer a lot of money because the customer decides to take the laptop to someone else who went and played a lot with this laptop. Because you saw, I fixed the issue. That was the power problem. Then later I had to correct the mistake which someone else created by programming the wrong BIOSes. Hmm? Yes, the laptop is fixed. Huh? Yes, thank you so much, guys, for being patient. It has been a very lengthy video, and I appreciate your patience. So, in case you have a problem with your laptop still, you can send it to us. We can fix it for you. As you can see, it took us a lot of time, but finally we managed to fix the issue. So, if you have a problem with your laptop, or you know someone who is having a big problem with this or a laptop, you can just connect them with us. Then we might be able to help. Again, if you are interested in learning about laptop repairs, you can also contact us. Then we can discuss on the logistics or we can accommodate you. We do over the training both online and offsite and on-site. That is, we are available physically and we are also available online. If you are interested in training with whichever module, you can just contact me. Then we can talk. So, guys, thank you so much. I'll just release you end this video, then I can assemble the laptop back, and we shall see each other in the next video. Please, guys, still, if you haven't subscribed, I'm still bleeding with you. Please do subscribe to our channel. I'm very happy when I see someone subscribe. When I see one person subscribing, I am really, really, really happy. We are heading to 1,000 subscribers, so please be one of our families. Yes, be one of us by subscribing, sharing with your friends, and bye bye. See you in the next video, guys.